When you need to solve a system of equation, graphing is one method. This would be the second method, and it's called the substitution method. And this is what you need to look for. When you see yourself set up where one of the variables is isolated and all by itself, like this y is here, it's perfect to do the substitution method. So let's take a look at what we do from here. I know that a system of equations solution needs to make both of the equations true. So if y is equal to -6 in the second equation, then I know that the y right here also needs to be equal to -6 in the first equation if it's a solution. And it is, because it tells us that in the second one that y is equal to -6. So this is what we do. We rewrite the first equation, -3x minus the 2, and now we make this y right here into the -6. And now we can go through and solve for this x value. So -3x minus 2 times -6 equals -6. To follow our order of operations, basically we need to multiply -2 times -6, and that equals +12. Everything else we can pull down now. And we have a nice, easy two-step equation. Let me pull that down just a little bit more. There we go. So -3x is going to be equal to -18. And we know that x equals 6. So here's our solution. X is equal to +6, and the y is equal to -6. That was given to us. Example 2 is very similar, but instead of them giving us y, they give us an x. So any place that I see an x value, I'm going to plug in a -1. So let's see, 2 times -1 plus y equals 4. 2 times -1 is -2. And now I can just add 2 to both sides, and I have my y value. So there we go. Here's our solution. We're going to write it as an ordered pair. My x was given to us, that's a -1, and y is +6. This ordered pair makes both of the equations true. Let's go down and take a look at a little bit more of a advanced type of situation here. This time I don't have y equaling a number, I've got y equals -4x. So any place that I see the y, I'm going to take it out and I'm going to put in the -4x. So let's rewrite this whole equation. -7x. See this minus sign? That needs to be put right there. What does this y become equal to? Well, this y is equal to -4x. If y is equal to -4x in the first equation, this y could be -4x in the second equation. The most important thing to remember, though, is that if this is a minus sign right here, it still needs to be here. And then if I'm putting in a negative number or a negative term like this, -4x, I need to put in that negative term, and so we see the minus negative setup, which lets us be able to rewrite it like this. And now I can combine like terms. -7x plus 4x is -3x. And now I can divide both sides by -3. So x is going to be equal to -6. So I'm going to go ahead and write the solution right here and plug in this -6 for my x value, because that's what x is equal to. And now we can sit here and kind of ponder about how do we figure out the y value. I want to kind of draw a little bit of an area off to the side so we can focus on that. I know what x is now. I still don't know what y is. I can't put -4x in there like that. I'm sorry, that's just not allowed. It's got a variable in there. So instead, I'm looking at these two equations, and I ask myself, now that I know x, I could plug in -6 for x any place I see it. I can plug in -6 here, or I can plug in -6 there. It becomes a choice about which one you believe is the least amount of work. So let's go ahead and use the first equation, because that sure is a lot easier. And where you see the x, literally plug in what you know x to be now, which is -6. So this is going to be multiplying by negative 6. Negative 4 times negative 6 is 24. So there's our solution for y. Just a little bit more work when you've got a variable on there for the value of the other variable. And then you get into this situation like example 4 down here, where quite frankly it looks hideous, but it's not very difficult. Y is equal to x. So let's go ahead and get our solution started over here. I'm going to write it as an ordered pair, two parentheses with a comma separating them. Y equals x. Well, I can't put a variable for my answer. What that means though is that any place I see a y, I can replace it with an x. Or any place that I see an x, I can replace it with a y. It's your choice. Personally, I look at this and I go, you know what? This y is equal to x. So this y, I'm going to replace it with x. So let's write it out. Negative 4x minus 3, and that's going to be multiplying to y, but y is equal to x. So let's just put an x here. Equals negative 14. Combine like terms, and you're done with at least that one variable. So x is equal to 2. Not bad. Let's go ahead and put a little bit of space here so that way I know this is me trying to get my other one. I could now plug a 2 in for x here or here. Well, this one looks a lot easier. So y equals x. You know, this is our x right there. X is equal to 2, so I just pop out the x and put in a 2. And I know that now y is also equal to 2. And just to take a little bit of time to prove that, hey, this solution is going to make both of these true, let's go check it. Y is 2, and x is also 2. So it made that equation true. Let's check the first equation. Negative 4 times x, which is positive 2, minus 3 times y, which is positive 2, equals negative 14. Let's see if that's true. This will make it negative 8. Negative 3 times 2 is negative 6. And negative 8 minus 6 is negative 14. So it does indeed make both of the equations true. This substitution method, again, is best when you see that one of the variables is isolated all by itself. You can use the substitution method when you don't have a variable isolated. You can manipulate the equation, and then you'd be able to isolate the variable and proceed just like we have normally.